So humans are going to Mars, and soon, lots of them. SpaceX could be going as soon as 2026, NASA and China by the 2030s, and India, Russia and the United Arab Emirates are all planning on it too. But what happens when they all get there? How can we actually survive? Well, some lucky scientists have already been there. Okay, not really. They're living in a Mars simulation right here on Earth to troubleshoot what could go catastrophically wrong when they do go to Mars. It's time to explore the unexplored. Okay, let's break this down into two key challenges we're going to need to overcome if we go to Mars: the physical and the psychological. Let's start with the physical. In many ways, Mars and Earth are quite alike. It has a similar dry land mass, volcanoes, craters, and its days are just 37 minutes longer than ours. What would you do with an extra 37 minutes? But that is where the similarities end, and it's the differences where the problems start. Gravity is just 38% of that on Earth. It means that you can jump higher, but you'll lose muscle mass. Imagine Dwayne "The Rock" Johnson training his chest every day with an 100-kilo bench press to maintain that impeccable physique. Suddenly, you land on Mars, and all that's available is a 38-kilo weight. Over time, his chest is going to get weaker and weaker. And it's a similar situation for astronauts going to Mars. Then there's the atmosphere, which is incredibly toxic. It's around 95% carbon dioxide. And to make matters worse, Mars is bombarded with radiation. And you get the idea. Mars is extremely dangerous. But luckily, there's a team of scientists who are actively trying to resolve these problems before we get there.
So when we talk about Mars simulations, what we're doing is we are trying to mimic the surface phase of a human robotic Mars mission. There's a million things that can go wrong. So when we think about Mars, we're talking about a world that is up to 380 million kilometers away from the Earth, which happens to be about 1,000 times the distance to the Moon. And so it's probably 1,000 times more things that can go wrong. What we learned through our missions, it's not only the big things that are challenging, it's the small things. Think of being in the spacesuit. Despite the air condition, you start to sweat, but you cannot scratch your nose in the helmet, obviously. So little things like a little piece of foam where you can simply rub your nose into it and make sure you don't sneeze inside the helmet, which is a very bad idea, by the way, is a little thing that doesn't sound very glorious, but it's the things that make your work easier. And really making sure that you have gone through the ins and outs of those little details can be a game changer. We have been doing those Mars simulations for 13 campaigns now, since almost 20 years now. And there's literally hundreds of experiments we did, and many of them went wrong or did not turn out the way like we expected them to do. And so we live and breathe the mantra of fail fast, fail cheap, and have a steep learning curve, because that's where you get better. We died many deaths, simulated, of course.
So gravity, atmosphere, and radiation are not actually the main concerns. These are the big things that we already know about, that we can create technology to help mitigate them. It's the small things that we don't know about yet. They're what could kill you, and there's a lot of them. So far, the answer to most of the physical challenges has been better technology and better spacesuits. But physical survival is only part of the battle. The team are also pioneering incredibly advanced psychological studies to figure out who will be the best humans to go to Mars.
We think that there's no such thing as a born astronaut. When we select analog astronauts for the Austrian space program, this has been done very, very carefully. It's a multi-month process. We're evaluating, we just did a recent count from the last class, 637 individual parameters, anything from your cholesterol level to the length of your pinky finger and your ability to entertain little children and psychological factors and so on. You're much more looking for team players who are outstanding when it comes to health, but they also have technical competence, but at the same time who are also to display social warmth. They know how to tell a joke in the airlock at the right time. They know how to cook. They know how to do a magic trick. They can play the guitar. They can also settle down a broken leg or so. We are not looking into psychological clones of each other, but they need to complement each other. And so we're looking actually from the anthropometric point of view, we're looking for the average Joe, the average Jane.
Or an average Josie?
So we have people who in the beginning who have a high technical competence, but then the work doesn't stop here, because you need to continuously monitoring the activities throughout the mission. That's exactly what we're doing with our simulations. For instance, we are in a previous experiment in 2018 in Oman, we had an artificial intelligence machine learning algorithm actually, who was looking into the pitch of the voices when people talk to each other. And we know when people are under stress, the average pitch shifts just slightly above the average. Or for this mission in Israel right now, we had one of the experiments. It was a fantastic experiment. The astronauts would have locators, so we could produce heat maps where the astronauts would congregate throughout the mission, or also relative heat maps, how much physical spacing they have in between them. If you don't like somebody, you tend to increase the distance, for instance. And so we're looking at the methods that tell us, here's a stressful situation emerging before the people would realize it, and magically then everything goes according to plan. And so it's about keeping them functional by keeping them happy, by feeding them well, no food, no fight. But also making sure they don't smash each other's heads before leaving the lunar orbit.
So, with the right training, technological development, and people management, Dr. Gromer believes that we can definitely survive on Mars. But so far, we've only been focusing on a finite scientific mission. Go, survive for a bit, and then return. And that's understandable, given how many risks there are for even doing that. But this hasn't stopped people from dreaming even bigger. Elon Musk has famously said that we're going to Mars for good, to become a multi-planetary species. Some scientists have taken this and come up with some scary, speculative solutions to explain how we might survive. One of those is through mutations. The high levels of radiation on Mars could cause our bodies to change, and it's possible that some of these changes might actually help us survive. It's hard to predict how quickly this might take and the effects that it might have, but some scientists say that it could take just a few generations. Like, we could see changes in our skin tone to deal with the radiation. Could we go green? Our bone density might alter to account for the lack of gravity, and we might not even need our immune systems because we'll be living in such a sterile environment. But all of this is only relevant if we're actually going. Will we really ever be setting off to Mars for good?
Yes, we will. I can give you this in written. It's only a natural process. I think at the core of our beliefs and of our heart and our DNA, we are a migratory species. Our children and grandchildren will look up to the sky, to the moon, and see little dots of light out there on the lunar surface saying, we are out there. It's a statement to the universe. And the same will happen to Mars and the worlds beyond. It's just a matter of time.